In this video, uh, I'm going to discuss inverse Laplace transform based on region of convergence. So, in order to discuss this particular topic, so I'm going to use one problem. So, the problem given us, the question is find inverse Laplace transform. Find inverse Laplace transform using partial fraction expansion method of transfer function x of s equals to 3 by s plus 1 into s plus 4 if the region of convergence is point number 1 real part of s is greater than minus 1. Point number 2 real part of s less than minus 4. Third one is real part of s in between minus 1 and minus 4. So this is the question given. So the main purpose of this question is to find the inverse Laplace transform using partial fraction method. So for the specific region of convergence. Right? So in first case it is given greater than minus 1. Second case it is less than minus 4. Third case is in between minus 4 and minus 1. So we need to find out the inverse Laplace transform for the specific region of convergence. So we will simplify this one, the solution. So given x of s equals to 3 by s plus 1 into s plus 4. Now we use partial fraction expansion. So here is 3 by s plus 1 s plus 4. The simple roots are there, simple poles. So in that case we can write the partial fraction expansion as a by s plus 1 plus b by s plus 4. So now we find out the values of a and b using partial fraction simplification approach. So that equals to, so we can take the LCM on right half side. So s plus 1 into s plus 4. The numerator it becomes a into s plus 4 plus b into s plus 1. So now denominator on both sides become cancelled. And the numerator is 3 equals to a into s plus 4 plus b into s plus 1. So this is the expression. So from this we try to find a and b. So for that purpose, what we do is first we make b is 0 then find the A. Similarly, then make A is 0 and find the B value. So for that purpose, so put S is equal to minus 1 in the first case. So then 3 is equal to, so when S is minus 1, so B becomes 0, minus 1 plus 1 is 0, and B into 0 is 0. So then we have A minus 1 plus 4. So that equals to 3 equals to 3A. Then we find A is equal to 1. So this is A. Similarly, we repeat the same process for B. So put S is equal to minus 4. So now A becomes 0, minus 4 plus 4, 0, 0 into A is 0. And then B is B of minus 4 plus 1 equals to 3. So minus 3B equals to 3, thereby B value is equal to minus 1. So A is 1 and B is minus 1. So now we substitute this A and B values in the basic expression. Then we will get x of S equals to A by A is 1 by S plus 1, B is minus 1 by S plus 4. So now we find the inverse Laplace transform for this one. So apply the inverse Laplace transform on both cases. So Laplace inverse of x of S equals to Laplace inverse of 1 by S plus 1 minus Laplace inverse of 1 by S plus 4. So that equals to Laplace inverse of x of S is x of t, and Laplace inverse of 1 by S plus a. So this is in the form of Laplace inverse of 1 by S plus a. So that equals to e power minus at. So this here will get e power minus a in the a position we have 1, so e power minus t. So to represent the unilateral Laplace transform, a right sided function, so we multiply this signal with u of t minus, so e power minus at. So in the position of a we have 4 e power minus 4t. So to indicate the right sided function, so we use u of t function here. So this is the normal or general inverse Laplace transform for the given function. Okay. So now for based on the conditions given, so we need to find the Laplace inverse Laplace transform for the given region of convergence. So first thing is, the first point given as real part of S is greater than minus 1. Real part of 1 is greater than minus 1. So for this, first what we do is we draw the region of convergence in S plane. So for that we consider S plane. So this is real axis and this one is imaginary axis j omega. Now the real part of S is greater than minus 1. So minus 1 is on negative axis. So here is minus 1. Okay. So now the greater than minus 1 is the region of convergence. So here we write minus 1 and greater than minus 1 is a, and we use the two poles given in the transfer function. So in the two poles are, so one is minus 1 and second one is minus 4. These are the two poles so given in the transfer function. So one at 1 we have one pole minus 1 and minus 4 is the second pole. Okay. So now as per the given condition, real part of S is greater than minus 1, meaning is that our sigma greater than minus 1. So the ROC is exist, region of convergence is exist greater than minus 1. So that at minus 1 we draw a vertical line like this, a dotted vertical line, and after that up to positive axis, so we draw lines like this, horizontal lines, to represent the ROC. So ROC is real part of S is greater than minus 1. Okay. So entire right side of this minus 1, so we have a region of convergence. Okay. So now we can observe from this diagram, from this ROC plot, is two poles minus 4 and minus 1. So for the two poles the ROC is right side. So when for any pole the ROC is right side, then we can write the inverse Laplace transform as it is. Okay. So we write a simple comment here like ROC is right side to pole at S is equal to minus 1 and S is equal to minus 4. Therefore, it is a causal right? It is a causal system. You can say that it is a causal system. So then ROC is right side to the both poles. So we can write it as the inverse Laplace transform x of t is as it is what we written in previous case. X of t is equal to e power minus 4 e power minus t e power minus t, whatever we just mentioned here, e power minus t u of t minus e power minus 4t u of t. Without any changes, we write the inverse Laplace transform, inverse Laplace transfer function for the given signal. The second one here given as real part of S is less than minus 4. So our real part of S in the sense sigma, so is less than minus 4. So now for this we draw the ROC or S plane. So this is real axis and imaginary axis j omega. Now the mark two poles given as per the given transfer function. So one is at minus 1 and second one is at minus 4. Now it is less than minus 4. So less than minus 4. So have a region of convergence. So at minus 4 you draw a vertical line, dotted vertical line like this. And condition is given as less than minus 4. So less than minus 4 means it is left side to this. So you draw the lines like this. So this indicates ROC. So now if you observe this one, so ROC for the given condition is left side to both the poles. Okay. So when the ROC is left side to the poles, then we change the polarities or sign to the inverse function. So here we write the comment. The ROC is left side to both poles of S is equal to -1 and S is equal to -4. So when this ROC is left side, then we need to change the polarities, right? So the basic one, basic inverse Laplace transform. So we identified is normal, what we have called normal inverse Laplace transform, e power minus t u of t minus e power minus 4t u of t. Now we change the polarities. So before e and in unit step case. Okay. So we negate the function. So that is the inverse Laplace transform for the given ROC is x of t equals to. Now we need to change the sign for both the functions. So minus e power minus t and u of t, which reverse the function, right? U of minus t, it becomes u of minus t now, plus minus minus, it becomes plus, and e power minus 4t, again this is u of minus t. Okay. So this is the inverse Laplace transform for the given ROC function, the given region of convergence. So now the third case, we'll move to the third case. Third case is in between -1 and -4. So case number 3, point number 3. So region of convergence, real part of S, is in between -1 and -4. So R sigma value is less than -1 and greater than -4. So this is the case. For this, we draw the pole 0 plot or S plane. So this is real part and imaginary part, j omega. Now we mark the two poles. -1 is one pole and second one is -4 is the another pole. Now the region of convergence is in between -4 and, so draw a vertical lines at two poles. First mark the region of convergence as given in the question. So now is in between the two cases, right? In between -4 and -1. So now if you observe the pole -1, so for the pole -1 it is left side, so we need to change the polarity of sign of this pole, right, in the respective function. And for the -4 pole at -4, it is right side, so we can write the inverse Laplace transform for the pole -4 as it is, and for -1, so we reverse the. So first we try to write the comment here. The ROC is left side of a pole at S is equal to -1 and right side to the pole at S is equal to -4. So you remember that. So for right side function, so we can take the inverse Laplace transform as it is to the normal case. So when it is left, then we change the polarity before that, and similarly in the unit step function. Therefore, the inverse Laplace transform based on ROC, given ROC here, is x of t equals to, now observe that for minus 1 is e power minus t u of t. So here we have a function e power minus t u of t, normal function. But now it is left side to this. So we can change here, right? So because of the left, so we write minus here and similarly minus here. For minus 4, so it is e power minus e power minus 4t u of t. So we write as it is because it is a right side. So we write the function as it is, and for this one, so we can write the new polarity. Okay. So now this equals to, first we write the minus 1, so it becomes minus e power minus t u of minus t minus e power minus 4t u of t. So this is the inverse Laplace transform for the given ROC. Okay. So this is the case how to find when the ROC is given, and based on the ROC the inverse Laplace transform is computed by following this procedure. Okay. Thank you.